A cosmic wanderer's threat from Earth to Moon. The void of space stretched endlessly, a silent expanse where stars burned in distant indifference, and among them sailed a rocky intruder, a jagged relic of the solar system's birth. Asteroid 2024 YR4, a tumbling mass of stone and metal roughly the size of a 10-story building, carved an elliptical path through the cosmos, its orbit bringing it perilously close to the Earth-Moon system. Discovered in December 2024 through a telescope in Chile's Atacama Desert, it sparked global alarm when initial calculations suggested a 3% chance of colliding with Earth in 2032. A city killer capable of devastating a metropolis. Yet as observatories trained their lenses and the James Webb Space Telescope's golden mirrors captured its faint glow, the threat shifted. Earth was safe, but the Moon, humanity's silent companion, emerged as a new target, with a 3.8% chance of impact. The asteroid, once a harbinger of terrestrial doom, now loomed as a lunar specter, its journey a cosmic drama unfolding in the starry dark. The asteroid's form, revealed by JWST's infrared gaze, was an irregular, cratered mass, its surface scarred by eons of collisions and bathed in the harsh radiation of space. Measuring 53 to 67 meters across, it was small by cosmic standards but formidable enough to unleash chaos if it struck. Its orbit, a looping trajectory that swung it between Mars and Jupiter before diving toward Earth's vicinity, marked it as a near-Earth object, NEO, an Apollo-class asteroid whose path crossed Earth's own. Traveling at speeds up to 19,000 miles per hour, it tumbled through the void, its rocky composition, possibly iron-rich, denser than softer carbonaceous asteroids, making it a potential force of destruction. The Moon, with its thin exosphere and pockmarked surface, offered little resistance, its craters a testament to billions of years of such impacts. Yet this asteroid's approach was different, a rare event in humanity's watch, its trajectory a puzzle that demanded scrutiny. The initial fear of an Earth impact had gripped the world, the 3% probability, unprecedented for an NEO, evoking visions of a fiery descent, a blast rivaling nuclear devastation, and a crater scarring the planet. Scientists at NASA's Center for Near-Earth Object Studies, CNEOS, alongside global observatories, worked feverishly, their telescopes tracking the asteroid's faint gleam against a backdrop of stars. Early data, clouded by a bright full moon, yielded uncertainty, but as observations refined its orbit, relief emerged. The chance of hitting Earth plummeted to 0.004%, a near-zero risk. The JWST, redirecting its cosmic gaze from distant galaxies, provided critical infrared images, narrowing the asteroid's size and trajectory. Yet the data unveiled a new concern, a 3.8% chance of striking the Moon on December 22, 2032, a probability high enough to shift the focus skyward, where the lunar surface waited, silent and exposed. The implications of a lunar impact were both subtle and profound. Unlike Earth, protected by its atmosphere that incinerates smaller rocks, the Moon would absorb the asteroid's full force, potentially creating a crater hundreds of meters wide and ejecting debris into space. Scientists speculated that such an event could cloud the Earth-Moon system with particles, posing risks to satellites or lunar missions, though Earth itself would face little direct threat. The asteroid's iron-rich nature, suggested by its brightness, implied a denser impact, capable of carving a deeper scar than a softer body. Yet the Moon's orbit would remain unchanged, its gravitational dance with Earth unperturbed, as NASA reassured. The event, if it occurred, would be a spectacle, a rare chance to witness a cosmic collision in real time, offering insights into the solar system's violent past and the Moon's battered history. The challenges of tracking 2024 YR4 were as daunting as the asteroid itself. Its elongated orbit took it far from Earth's sensors by mid-April 2025, rendering it invisible until its next approach in 2028. Ground-based telescopes, limited by distance and light, struggled to keep pace, while JWST's brief observations provided only a snapshot of its path. Scientists faced a race against time, collecting data before the asteroid vanished, their models refining its trajectory with each new measurement. The 3.8% lunar impact probability, though small, was significant in planetary defense, a field honed by missions like NASA's DART, which tested asteroid deflection in 2022. The asteroid's unusual shape, hinted at by JWST, added complexity. Its irregular rotation could alter its path subtly, demanding precise calculations to predict its fate. The global effort, from Chile to NASA's JPL, was a testament to humanity's vigilance, its eyes fixed on a rock that had shifted from Earth's peril to the moon's uncertain future. The societal weight of this discovery was a blend of relief and intrigue. The asteroid's retreat from Earth's threat eased fears of catastrophe, yet its lunar trajectory sparked a new fascination. News of the city killer turned moon target spread, amplified by images from JWST and visualizations of a lunar strike. The public, accustomed to tales of apocalyptic asteroids, now pondered a cosmic event closer to home, a collision not on Earth, but on its celestial neighbor, visible in night skies. Scientists became storytellers, their data fueling debates about planetary defense and the moon's role in humanity's future. The asteroid, a mere speck in the void, had become a symbol of cosmic unpredictability, its path a reminder that the universe remained a place of beauty and danger, where even the moon could bear the scars of a wanderer's wrath. Humanity's vigil, tracking a cosmic threat. The asteroid 2024 YR4, a jagged shard of cosmic stone tumbling through the solar system's vast darkness, had shifted from a fleeting terror for Earth to a looming specter for the moon, its 3.8% chance of lunar impact in 2032, casting a subtle shadow over humanity's celestial ambitions. In observatories scattered across Earth's deserts and mountains, telescopes hummed with purpose, their lenses straining to capture the asteroid's faint glimmer before it vanished into the void's embrace by mid-2025. The James Webb Space Telescope, its golden mirrors briefly redirected from distant galaxies, had already offered critical glimpses of the asteroid's irregular shape and iron-rich surface, refining its trajectory. Scientists, their faces lit by glowing screens, worked tirelessly to unravel the asteroid's path, their efforts a blend of precision and urgency as they prepared for a cosmic event that could scar the moon's ancient face. Beyond the labs, the world watched, its imagination stirred by a rock that had transformed from Earth's peril to a lunar challenge, a reminder of humanity's fragile place in the cosmos. The scientific endeavor to track 2024 YR4 was a global symphony, uniting observatories from Chile's Atacama to NASA's Jet Propulsion Laboratory in a relentless quest for clarity. The asteroid, roughly 60 meters wide and denser than softer NEOs, demanded meticulous observation, its orbit a complex dance influenced by gravitational nudges from planets and its own uneven rotation. Ground-based telescopes, like those of the Pan-STARRS network, captured its fleeting light, but the bright lunar glare and the asteroid's growing distance posed challenges, reducing visibility until its next approach in 2028. JWST's infrared images, revealing a cratered, elongated form, were a breakthrough, narrowing the impact probability and confirming the moon as the primary target. Supercomputers churned through orbital models, accounting for subtle factors like solar radiation pressure or the Yarkovsky effect, where uneven heating could nudge the asteroid's path. Each datum was a thread in a tapestry of prediction, weaving a clearer picture of a potential lunar collision. The technological demands of this vigil pushed planetary defense to new heights. The asteroid's discovery, flagged by NASA's Sentry system in December 2024, underscored the need for advanced NEO monitoring, a field honed by missions like NEOWISE and the upcoming NEO Surveyor, set to launch in 2026. Scientists proposed new telescopes, optimized for infrared and radar, to track faint objects like 2024 YR4 across vast distances. Space agencies, inspired by NASA's DART mission, which successfully altered an asteroid's orbit in 2022, debated deflection strategies, though the moon's low strategic risk tempered urgency. Concepts like kinetic impactors or laser ablation, once theoretical, gained traction, with simulations testing how to nudge a 60-meter rock off course. The asteroid's iron-rich composition, suggested by its reflectivity, posed a challenge. Denser than carbonaceous asteroids, it would resist fragmentation, requiring precise force. These innovations, born of necessity, were steps towards safeguarding not just the Moon, but Earth's future against cosmic threats. The societal response to 2024 YR4 was a kaleidoscope of awe, fear, and curiosity. The asteroid's initial 3% Earth impact probability had sparked global panic, with headlines conjuring visions of shattered cities and darkened skies. As the threat shifted to the Moon, relief mingled with fascination, the public captivated by the prospect of a rare cosmic event visible from Earth. Social media buzzed with visualizations, artists' renderings of a fiery lunar strike, or telescopic images of the asteroid's scarred surface. Schools incorporated the asteroid into lessons, teaching children about NEOs and planetary defense, their eyes wide with wonder at a rock that could reshape the Moon's craters. Public forums debated the implications, from satellite risks to the allure of witnessing a collision, transforming 2024 YR4 into a cultural phenomenon, a symbol of humanity's growing awareness of its cosmic neighborhood. The cultural impact wove the asteroid into humanity's narrative, blending science with imagination. Documentaries traced its journey, their narrators recounting the shift from Earth's doom to the Moon's target, while artists painted skies ablaze with the glow of a lunar impact. Writers crafted stories of astronomers racing to save the Moon, their tales echoing the real-world efforts of NASA and ESA. Observatories opened their doors, hosting stargazing events where families peered through telescopes, hoping to glimpse the asteroid's faint dot. The Moon, long a symbol of dreams and exploration, took on new meaning, its surface a canvas for a potential scar that humanity might witness. The asteroid, though distant, had become a touchstone, uniting people in a shared gaze at the heavens, where a single rock could rewrite the story of Earth's closest companion. The asteroid's significance extended beyond immediate fears, fueling a broader vision for humanity's future. The 3.8% lunar impact probability, though low, highlighted the need for robust planetary defense, prompting international collaborations to fund NEO tracking and deflection technologies. The Moon, with its growing role in space exploration, bases planned for the Artemis program, became a focal point, its safety now a priority. Scientists speculated that a 2024 YR4 impact could yield data on lunar geology, with ejected debris offering clues to the Moon's subsurface. The asteroid's approach, a rare natural experiment, galvanized efforts to prepare for future threats, from city killers to extinction-level rocks. In the glow of observatories and the hum of mission control, humanity stood vigilant, its eyes fixed on a cosmic wanderer that had shifted from Earth's menace to the Moon's uncertain fate, a challenge that would shape its destiny among the stars. A lunar legacy, humanity's destiny in the cosmic crosshairs. The asteroid 2024 YR4, a rugged relic of the solar system's dawn, sailed through the starry void, its jagged form a silent harbinger of change for the Earth-Moon system. By 2032, its 3.8% chance of striking the Moon had become a defining moment for humanity, a cosmic event that had transformed a fleeting threat into a catalyst for progress. Observatories, their telescopes now joined by orbiting sentinels, had tracked the asteroid's path with unwavering precision, its orbit refined through years of data from the James Webb Space Telescope and ground-based arrays. The Moon, humanity's ancient companion, stood poised to bear a new scar, its pockmarked surface a canvas for a collision that could reshape not just its geology, but humanity's vision of its place among the stars. The asteroid, once a shadow over Earth, had become a beacon, its potential impact a spark that ignited a new era of exploration, defense, and cosmic awareness. The scientific legacy of 2024 YR4 was a revolution in planetary defense and lunar science. The asteroid's discovery had galvanized a global network of observatories, from NASA's NEO surveyor to ESA's FlyEye telescopes, their advanced sensors now capable of spotting city killers years in advance. The 2028 approach of 2024 YR4, when it swung closer to Earth, provided a trove of radar data, revealing its elongated, iron-rich structure and confirming its lunar trajectory. Scientists prepared for a possible 2032 impact, deploying lunar probes to monitor the event, their instruments poised to capture seismic waves and debris clouds. A lunar strike, though unlikely to disrupt the moon's orbit, promised insights into its subsurface, with ejected material potentially exposing ancient volatiles or minerals. These findings fueled plans for lunar mining, supporting bases envisioned under NASA's Artemis program, transforming the moon from a passive target into a cornerstone of humanity's cosmic ambitions. The challenges of preparing for the asteroid's approach were as formidable as the cosmos itself. Tracking 2024 YR4 beyond 2028 required next-generation telescopes, their orbits free from Earth's glare, to maintain contact as the asteroid looped toward its 2032 rendezvous. Deflection technologies, though advanced by DART's success, faced hurdles. 2024 YR4's density demanded powerful kinetic impactors or gravitational tractors, with missions needing years to reach it. International coordination was critical, as space agencies debated whether to intervene or let nature take its course. Given the moon's low strategic risk, the asteroid's irregular rotation, hinted at by JWST, added uncertainty, its tumbling path defying simple predictions. Scientists also faced the challenge of public perception. Balancing the excitement of a rare event with the need to avoid panic, their models a delicate dance of probability and precaution in a world now acutely aware of cosmic dangers. Society, reshaped by the asteroid's journey, had woven 2024 YR4 into its cultural tapestry. The moon, long a symbol of wonder, took on new significance as a potential impact site, its craters a reminder of the solar system's violent history. Public fascination grew, with night skies filled with amateur telescopes trained on the moon, hoping to glimpse the asteroid's approach in 2032. Art flourished, with murals depicting fiery lunar collisions and sculptures of the asteroid's rugged form adorning city squares. Literature spun tales of lunar colonists bracing for impact, their stories blending science with human resilience. Education systems taught the asteroid story, inspiring a generation to pursue careers in space science, their minds ignited by a rock that had shifted humanity's gaze upward. The asteroid, a mere speck in the void, had become a unifying force, its potential strike a shared moment in a fragmented world. The cosmic role of 2024 YR4 extended beyond the moon, positioning humanity as a steward of its solar system. Space agencies, bolstered by the asteroid's wake-up call, expanded planetary defense networks, with satellites patrolling for NEOs and deflection missions ready to launch. The moon, now a hub for exploration, hosted observatories and research stations, their data informing strategies to protect Earth and its celestial neighbor. International treaties forged in the asteroid's shadow ensured collaboration on future threats, from city killers to extinction-level impacts. The 2032 event, if it occurred, would be a spectacle, visible from Earth with telescopes, its flash a rare chance to witness cosmic creation in real time. This moment, broadcast across screens, would cement humanity's commitment to space, transforming the moon from a passive target into a frontier for science and survival. The ultimate legacy of 2024 YR4 was a new humanity, one that embraced its role as a cosmic guardian. The asteroid, with its shift from Earth's threat to the moon's target, had redefined humanity's perspective, its potential impact a catalyst for unity and progress. Technologies born from its tracking, advanced telescopes, deflection systems, lunar probes, were seeds for a future where humanity thrived beyond Earth, on the moon, Mars, and beyond. The asteroid's journey, a fleeting arc through the solar system, had left an indelible mark, its story a reminder that even small rocks could shape destinies. As 2032 loomed, humanity stood ready, its eyes fixed on the moon, where a cosmic wanderer might etch a new chapter in the sky, proving that in the face of the unknown, a species could rise to meet the stars.